Our solar system is a familiar place. We have the sun, the planets, and even humble Earth. But what if our cosmic home wasn't born here? What if it originated in a completely different galaxy? This is the startling possibility that astronomers are now considering. Evidence suggests that our solar system might be a cosmic immigrant, brought here billions of years ago from a small galaxy called the Sagittarius Dwarf Galaxy. This theory challenges everything we thought we knew about our place in the universe. It implies that our solar system has been on an incredible journey, crossing vast distances of interstellar space. Imagine our sun, a young star at the time, carrying its retinue of planets across the cosmos. This notion is both awe-inspiring and a little unsettling. It forces us to reconsider our cosmic narrative and delve into the mysteries of our galactic neighborhood. The idea that entire star systems can migrate between galaxies is a relatively new concept in astronomy. It stems from observations of galactic mergers, a common occurrence in the universe. Galaxies, much like living organisms, interact and even consume each other. Our own Milky Way is no exception. It has a long and violent history of merging with smaller galaxies, tearing them apart and absorbing their stars and planets. This galactic cannibalism is a key piece of the puzzle when we consider the possibility of our solar system's extragalactic origin. It suggests that our sun and its planets could have been part of a larger structure that was devoured by the Milky Way long ago. The Milky Way, our home galaxy, is a cosmic giant. It spans over 100,000 light-years across and contains hundreds of billions of stars. But beneath its serene beauty lies a history of violence and destruction. The Milky Way is a galactic cannibal, growing larger and more massive by consuming smaller galaxies that venture too close. This process of galactic merging is a fundamental aspect of galaxy evolution, shaping their structure and stellar populations over billions of years. Throughout its long lifespan, the Milky Way has engaged in numerous acts of galactic cannibalism. It has devoured countless dwarf galaxies, leaving behind faint streams of stars as remnants of these ancient feasts. One such victim, the Sagittarius Dwarf Galaxy, is of particular interest to astronomers. This small, elongated galaxy is currently being torn apart by the Milky Way's gravitational forces. Stars and gas from the Sagittarius Dwarf are being stretched out into long, tidal tails that wrap around our galaxy. The encounter between the Milky Way and the Sagittarius Dwarf Galaxy is not a one-time event. These two galaxies have been locked in a gravitational dance for billions of years, repeatedly passing through each other. Each passage strips away more material from the Sagittarius Dwarf, leaving it increasingly disrupted and eventually destined for complete assimilation into the Milky Way. This ongoing interaction has profound implications for our galaxy, influencing its structure, star formation, and even the evolution of our own solar system. As the Milky Way continues to feast on the Sagittarius Dwarf, it leaves behind a trail of evidence. This evidence comes in the form of stellar streams, groups of stars that share a common origin and move together through the galaxy. By studying these streams, astronomers can reconstruct the history of galactic mergers and uncover the secrets of the Milky Way's past. Imagine a telescope so powerful that it can map the positions and movements of over 1 billion stars in our galaxy. That telescope is Gaia, a space observatory launched by the European Space Agency. Gaia is revolutionizing our understanding of the Milky Way, providing unprecedented details about its structure, evolution, and the history of its stellar inhabitants. One of Gaia's most remarkable discoveries is the detection of numerous stellar streams in the Milky Way. These streams, often faint and difficult to observe, are remnants of past galactic mergers. They represent the stretched-out remains of dwarf galaxies and star clusters that have been torn apart by the Milky Way's gravity. Each stream tells a story, a cosmic chronicle of a galaxy long gone. Of particular interest is the Gaia Sausage, a massive stellar stream that stretches across the Milky Way's halo. This stream is believed to be the remnants of a dwarf galaxy that collided with the Milky Way billions of years ago. The collision was so violent that it shook the Milky Way to its core, triggering waves of star formation and shaping its structure. Gaia's observations have provided compelling evidence to support the theory that our solar system might have originated from the Sagittarius Dwarf Galaxy. By analyzing the chemical compositions and movements of stars in the Sagittarius stream, astronomers have found striking similarities to our own sun. This suggests that our star and its planets could be remnants of this ancient galactic collision, adopted into the Milky Way billions of years ago. Cosmic Dance. The ongoing saga of the Milky Way and Sagittarius Dwarf. The Milky Way and the Sagittarius Dwarf Galaxy are locked in a cosmic dance, a slow and graceful waltz that has been ongoing for billions of years. This dance, however, is far from harmonious. It is a story of gravitational tug-of-war, with the Milky Way, the more massive partner, slowly consuming its smaller companion. As the Sagittarius Dwarf Galaxy orbits the Milky Way, it experiences tidal forces. These forces, similar to the tides on Earth caused by the Moon's gravity, stretch and distort the dwarf galaxy. Stars and gas are pulled away from the Sagittarius Dwarf, forming long tidal tails that wrap around the Milky Way. These tidal tails are a testament to the ongoing interaction between these two galaxies, a cosmic ballet played out over eons. The effects of this cosmic dance are far-reaching. As the Sagittarius Dwarf plunges through the Milky Way's disk, it triggers star formation. The compression of gas and dust during these encounters ignites the birth of new stars, enriching the Milky Way's stellar population. The Sagittarius Dwarf also influences the structure of the Milky Way's spiral arms, creating ripples and disturbances that propagate throughout the galaxy. This ongoing interaction between the Milky Way and the Sagittarius Dwarf Galaxy is a reminder of the dynamic nature of our universe. Galaxies are not static islands in space, but rather constantly evolving and interacting with their surroundings, and as we continue to study these interactions, we gain a deeper understanding of our own galaxy's history and our place within the vast cosmic tapestry. The Kuiper Belt, a graveyard of cosmic encounters. Beyond the orbit of Neptune, far from the warmth of the sun, lies a realm of icy bodies known as the Kuiper Belt. This distant region of our solar system is home to trillions of icy objects, remnants from the early solar system's formation. The Kuiper Belt is a cosmic graveyard, preserving evidence of ancient events that shaped our solar system, including the possible influence of the Sagittarius Dwarf Galaxy. The Kuiper Belt is a region of intense gravitational interactions. The giant planets, particularly Neptune, exert their gravitational pull on the icy objects in this region, shaping their orbits and creating a complex and dynamic environment. The passage of the Sagittarius Dwarf Galaxy through the Milky Way's disk could have further disrupted the Kuiper Belt, scattering objects inward and outward and leaving behind a telltale signature of its gravitational influence. Astronomers are particularly interested in a group of objects in the Kuiper Belt that have peculiar orbits. These objects are clustered together in a way that suggests they are being influenced by the gravity of an unseen object, a hypothetical planet dubbed Planet 9. While the existence of Planet 9 is still debated, some scientists speculate that it could be a captured rogue planet, a wanderer from interstellar space that was ensnared by the sun's gravity. The Kuiper Belt, with its mysteries and its potential to hold clues to the solar system's past, is a prime target for future space exploration. Missions to this distant region could provide valuable insights into the early solar system's formation, the dynamics of planetary systems, and the possibility of capturing rogue planets from interstellar space.